Okay, there I am. It's a miracle. All right. Hello, 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 everybody. Forgot my camera. It's kind of weird and wonky, my camera. So, anyway, I'm here. Hello. How's it going, everybody? I hope everybody's doing okay. There we go. A little bit more centered. Oh, actually, a little off center. Off well, we'll figure it out. There. It's a little bit better. All right. Hello, hello, hello. Hello, everybody. I hope you're all doing well today. Because I am. All right. I need to change that font color on that chat box there. If I can. I should change it to something slightly a bit better. I should change it to that darker tone. Maybe that's a bit better. I don't know. I guess we'll figure it out as time goes along. That should be okay. All right, how's everybody doing today? So we are, excuse me here. We are going to get started in a couple of minutes. So we'll just get started here in a couple of minutes, and then we'll go ahead and get going with our lesson here for today. All right. Got a couple of sections to do here today, so it shouldn't be too bad to go over. All right, and get that thing going. Wow. Hello, Brennan. How are you, my friend? I hope you're doing well. I got your email, by the way. I sent you something back. So you should be okay. So this shouldn't be any problem. I don't know if you saw my email or not though. I sent it recently, so if you didn't, then I totally understand. Yeah. Yeah, so even if you accidentally just did the first, the first attempt, there's 3 attempts, and the best score that you get on the test is the one that's recorded. So the worst scores are the ones that are automatically thrown out anyway. So those are the ones that that matter the most. Is I take the best score there, so that's why there's like multiple attempts. In case if something like that happens, or again, you just want to review a second time and give it a try a second time. Like, hey, that's cool. So, Dr. Dan, my dude, how are we doing today? We're gonna get started. I'm very good. I'm very good, my man. We got um yeah, we only have a few weeks left. We are doing some more algebra here in chapter 7. So we're going to do the last couple of sections here from chapter 7 is what's on the agenda here for today. All right. And then we'll be doing like chapter 8 next time, and then chapter 9, and then chapter 10, and then that's the book right there. So we're getting down to the final throes of the semester here. We got today we got 1, 2, 3, 4. We got like 5 classes left. So yeah, it should be pretty easy to finish up the book in that amount of time, given the material that we have. So Really doesn't take long to kind of go through this. As a reminder here, remember that we will not have class here next Wednesday. Okay, that's for Thanksgiving holiday. So we're getting down to the we're getting very close to the end of the semester here, which is pretty positive. So getting down to the final throes of the book, get this chapter 7 done here today, and then chapter 8, all of chapter 8 next time, and then all of chapter 9 the following time after that, and then we get to chapter 10. We do our thing. So here we go. Got ourselves a winner chicken dinner. You know, all right. Um, hopefully we'll have a few more people here join us. If not, that's okay. It'll just be us here today. That is not a problem. All right. So why don't we go ahead and get started here with at least the new material here for today. So let's go ahead and do it. All right, let's do it. Okay, let's get started today. Welcome back. Welcome back, everybody, to Wednesday, end of the week time today. So today, we, like I mentioned here before, we are going to cover more about algebra that we discussed about here last time. We discussed about one-step and two-step problems here. Okay, so with one-step and two-step problems here, we talked about, again, how to balance things out. That was one of the most important things we talked about in algebra. Today, what we're going to do is we're going to look a little bit, we're going to look a little bit further here. All right, we're still going to reflect doing the same kind of problems that we did last time, but in some cases, maybe we need to be a little bit more abstract, okay? So let me go ahead and demonstrate what exactly that means here. So let's go over section 7.5 here to start with, okay? And then we'll work our way up from there, all right? Okay, so what we're looking at here is that we're looking at, let's say, when I say abstract, I really do mean abstract. So let's say we're given a formula here. And in this formula, we're not given any numbers, but we're asked to solve for a particular letter. So let's go ahead and look at an example here. So abstract. So solving for variables abstractly. We'll talk about the key here in just a moment. But let me go ahead and put down an example so we can see what we're talking about. Okay. So let's go with this formula here for just a second. And let's say I had, all right, t is equal to rp divided by r plus 2. Um, hmm? Oh, I see my face. Thanks, Brenton. I gotta remind myself. I keep thinking that it's like that. There we go. That'd be a little bit better. You don't have to see my face. All right, there we go. I was like, wait, what? Okay. Let me try that again. There you go. That's all I wrote for word there is put more equations and formulas and solving for variables abstractly. Okay. Sorry about that. Man, you get kind of into a groove and then you just kind of like saying, "Ah, yeah." My apologies. Thanks, Brandon. Appreciate you. Okay. All right, so here we're given, I say, all right, we have RP over R plus 2. And let's say we said, okay, we're going to solve for P. All right. So here's the big difference. In the last section or sections, we took a look at formulas that we were given and we're saying, okay, tell me what they give us like the value of R. They may give us the value of T. They may give us both here. And then they say, okay, well, then now solve for P with values for R and values for T put in. And you'd be like, okay, that's fine. We did some algebra in relation to that. And we went ahead and, solved for that remaining variable. Again, P would be equal to some number at the end of the day. And we call it a day. That's it. In this particular case, if we want to solve for P here, let's talk about the key here. In this instance is, how do we solve for P in a circumstance like this? The key is to basically do the same thing as if there were numbers. Okay? In fact, you're doing nothing different than what you did before. Okay? So that's essentially how I want you to kind of think of the mindset here, even if they're letters kind of floating around in the middle of space. All right? Then basically we want to go ahead and do the same things that we did last time, only with letters as opposed to numbers. How do I get paid from this dude? Well, I happen to work at 2 community colleges, Ryan. So that pay me, and then I do work. So yeah, and then I have my side hustle, and then I get a little bit of pay that way. So there you go. You got yourself a winner chicken dinner. You're doing this for about 20 years, kind of crazy to think about. All right. So if I looked at this problem here, let me go ahead and rewrite this down here so it's a little bit easier to see, because I have a couple things we want to do. All right. So let's think of our goal here, guys. All right. So let's think of our goal here. Our goal is to get P by itself. That's our goal. So what do you think we could do first in order to get P by itself? No. More like face-to-face for 20 years. It's the only reason I've been streaming. So what can we do here first? How can we, what's the first roadblock in our way? We want to get P by itself, because at the end of the day, we want P is equal to something. What's the first roadblock in the way here? What do you think we could do first here in order to solve for P? Go ahead and ask that question there. What do you guys think? Think about it this way. Again, we're not going to do anything different here. What if this was what if this was like what if this was like T is, let's say I had oh, there we go. Okay. All right, so that's correct. We want to multiply R plus 2 to both sides. Again, it's the same thing as if I had this. If I had like 3 is equal to 5P over 2, well, then I would multiply by 2 on both sides to start with. Okay. Now, that's just with numbers. Now, if I just said here, okay, replace the numbers with just an expression, But I'm not doing anything different. I'm still going to multiply by whatever's here on the bottom, which is r plus 2. That's correct. So we're going to multiply by r plus 2 on both sides. So this cancels out. All right. So here we got RT plus 2t. Actually, let me write it this way, so maybe I'll make it a bit easier. I'll write r plus 2 times t first, and then I'll distribute. Equals rp. We'll come back to that in a second. Okay, and what would I do next? Again, I'm trying to solve for p here. So what do you think I should do next to solve for p? What's that last step right there? Okay, divide by r on both sides, right? R is the next roadblock in our way. Again, if we had, say, 5p, for example, this is basically what's happening here. With just numbers, I would just divide by 5 on both sides. Well, instead of dividing by a number, I'm now just dividing by a letter. So I'm just dividing by r on both sides. The r's cancel out here. And so here I got r plus 2 times t divided by r here equals p. And I can distribute this t here to both things. So I get rt here plus 2t over r equals capital P. Okay, so all I did was just multiply t here into both of these terms here. So that's what I did for that last part. Okay, and then that's it. That's all I have to do if I want to solve for one of those variables. So you can see here, I'm not doing anything different than what I did from before. Again, it's the same exact process, the same exact thing, only with letters as opposed to numbers. Okay, we'll do another example here, but before we do, are there any questions about this example? Any questions at all? Any questions? No? Okay, cool. Let's go ahead and do another example then. All right, and let's see if we can guide ourselves through this one. All right. Okay. Which one do I think I want to do? That one's actually not too shabby. Let's do. I could just make that one. Alrighty. Let's do it. Sure. So we could have, say, yeah. Okay, let's go with this one here. This is the formula here from Fahrenheit over to Celsius. Okay, so I have degrees Celsius is equal to 9/5 times Fahrenheit minus 32. All right. So let's say we want to figure out what Fahrenheit is going to be here in this case. All right. All right, so tell me, let's go ahead and take a look here. We want to solve for F, all right? Okay, so let's take a look at what we should do first. What do you think we should do first here? What do you think would be a good idea? What should we do first? What do you think we should do first here, guys? Okay, divide by 9/5 to both sides. That's actually correct. So here, there's a couple ways you can approach this. You can multiply by 5, okay, on both sides first, or you can divide by 9/5. All right, and that's perfectly fine too. This one's, again, it's supposed to be a little bit tougher. So to be fair, if you didn't get that right away, I'm not going to blame you for it. Um, Again, we have 9/5 and 9/5. They'll cancel out. Now, if you divide by a fraction here, dividing by a fraction, if you remember what we talked about quite a while ago, so again, is we flip that fraction over and then multiply appropriately. So here we get 5 times the degrees Celsius over 9, all right, equals Fahrenheit plus 32. Okay, all right, so what do we do next here? I'm going to solve for F. What should we do next? Ooh, why did I put plus? That should be minus. Kind of matters. What should we do next? The last part here. Add 32 to both sides. Good. So we'll add 32 to both sides here. And so here we get 5/9 times dc here plus 32 equals degrees Fahrenheit. There you go. Okay, good. All right, and that's what we get here for our final answer. All right, good stuff. Any questions about that? Hopefully that's not too bad. Go ahead and bring up the book here. I know you guys are a little quiet today. Not sure why, but hey, that's nice. Is there? Nope. Okay. All right. Let's go ahead and take a look here at some more problems. This time, let's take a look at some word problems and do them together. Okay. So we're going to look at a couple of these. All right. And which one do we want to do? Sure. Let's go ahead and do that one here. We're going to do number 7. All right. So let's look at number 7 here specifically, and I'll make this a bit bigger to be easier to read. Okay. So number 7 says Allied Health. All right. Nurses use a formula known as Young's rule to determine the amount of medicine to give a child under the 12 years of age when the adult dosage is known. So we're given a formula here, and we're asked, okay, C is equal to AD over A plus 12. All right. And we have a couple parts here. So the first part here says, all right, work backward and find the adult dose in terms of the child's dose, i.e. solve for D. And then it asks us find D if they give us a couple of values here. If the C here is equal to 0.05 grams and A is equal to 7. Okay, well, let's follow suit and see what it would like us to do here. Let's follow the example here. All right. Okay. So let's first look at the formula here. All right. And I'm going to have you guys tell me what to do. So hopefully this won't be too bad. All right. Okay, so what we want to do is we want to solve for D. That's our goal here. All right, that's what we're going to be doing here. We're going to be solving for hello. We're going to be solving for D here. Let's do it. Okay. So what should we do first here? How are we going to solve for D? Multiply by, okay, good. Let's do that first. Let's multiply by A plus 12 on both sides. Nice. This will cancel out with this. Multiply by A plus 12 here as well. And by that whole quantity there. So that's what we have here so far. All right. And we'll go ahead and expand on this. So we'll distribute the C here to both ones. So we got A times C plus 12 times C. That's what we have here so far by just distributing the C there. Okay, and what's next? Remember, we got to solve for D here, so what do we do next? Divide by A on both sides. Good. That's right. Let's divide by A on both sides, and that's going to be our final answer for this. Is we get AC plus 12C all over A. All right, good. Nice job. All right, good job. Now, all we have to do next here, that's for part A. Let's take a look here at part B now that we have the first part done. So part B says, find D if C is equal to 0.05 and A is equal to 7. So here, let's say we're given a scenario here, and our scenario here is that C is equal to 0.05 and A is equal to 7. So we're just going to plop in the numbers here into the formula we found here in part A, and we're just going to see exactly what works out. All right. Okay. So so A here is 7. C here is 0.05. We're just going to plop in numbers. We're just going to be able to do it out on the calculator there. So we have 12 times 0.05. We're going to divide that by 7. Okay. And so, again, I just expect you to do the calculator. Make sure to do the top part here first. So again, 7 plus 0.05. Okay, so 7 times 0.05, pardon me. Apologies. And then we'll add that to 12 times 0.05. And then we'll divide that by 7. Okay. Okay, does anybody have an answer for me here? We'll go to 2 decimal places here for this. So what is our final answer? Yeah. Your answer is going to be pretty small, so it should be okay. All right, I'll just wait. You guys can tell me once you guys got the answer there. All right, what do we get, guys? I'm going to keep waiting until somebody gives me an answer, so I don't mind waiting for a while. All right. Very nice. That's correct. So we'll go to 2 decimal places here, and we'll get 0.14. Very nice. Nice job. Okay. All right. Good. How long of a let me ask this question here. I do want to ask this question here because let's see if I can at least mitigate the delay here. About how long the delay is from typing it and it showing up on the screen there. So I just want to know. Oh, you have me muted. Hey, don't mute me. Hey, I'm trying to help you here. Sadness. All right, no, that's fair. No, I totally understand that. All right, good. So that's our first question there. Let's go ahead and do another one here. All right. Yeah, that one's actually a good one. All right, let's do one more from this section. We'll move on. Yeah. Okay. So the next one here is at the bottom of this page here. Is going to be number 14. Okay, so the formula here, A equals P times 1 plus RT, is used to find the total amount A of money in an account when an original amount or principal P is invested at a rate of a simple interest R for T amount of years. How long will it take for $8,000 to grow to $10,000 at a 4% simple interest? Okay, so for a problem like this, you may see a problem like this, and for homework and whatnot. And so one of the most important parts here for this particular one is just going ahead and just writing down the formula and just noting what each part means first and foremost. Let's say again, we talked about it last time. We said, all right, knowing what each letter means is incredibly important, so we know where to plop in the numbers there and then start to work with it. So in this case here, we're talking about simple interest. So A here is going to be the ending amount. This is how much we want here at the end of the day. So just going by the context of the problem here, I'm just going to label each one here. P here is the initial amount, or again, the initial deposit or principal. This is principal, or again, the beginning amount. So how much we started with. We have the interest rate here. One thing that is important about the interest rate, by the way, I will point this out here specifically for a problem like this, and I think it's I think it's important here. Interest rate here is in decimal. Okay, so interest rate here for this formula is in decimal. It's a percentage. I know it's a percentage, but again, most percentages are converted into the decimal there. My face is block. Oh, my face is blocking notes. Sorry, Jasmine. All right. There you go. That's my comment there. Oh my gosh. I won't let you read the notes. No. Forget you. Yeah, sorry about that. All right, and T is time and years. All right, very good. Very good. All right. Okay, so this is basically how the simple interest works in terms of a formula. Okay, let's go ahead and reiterate here once again. A is the ending amount, P is the beginning amount, or principal, R is the interest rate, which we'll put in decimal, and T is time in years, according to the problem here. So this is, like I said, this is one of those problems you'd be like, okay, it's not terrible, but again, just know what each of the letters represent, so we know exactly what we're working with here. Okay, now we're given the fact that we're trying to grow $8,000 to what are we trying to grow it to? $10,000. So we're given certain amounts here in this problem. The ending amount here that we should have is going to be $10,000. That's how much should be in our account here. If I go back to our problem here really quickly, just for a brief second, notice it says we want to grow to $10,000. So at the end of putting in this deposit of money, I should go from $8,000 to $10,000 after a certain period of time. Okay. Basically we're just trying to collect interest, and we're like, okay, yeah, let's try and collect interest, and how long is it going to take to sit there until I can get an extra, say, a couple $1,000s in interest. All right, that's fine. All right, let's go back to our problem here. Now our beginning amount here is we initially deposited $8,000. Okay, so $8,000 is our initial amount. Our interest rate is 4% according to this problem here, so I'm just going to state that without having to go back and forth here. 4%, really quick here. What is 4% as a decimal? What is 4% as a decimal? Because we do need to put this interest rate in decimal here. So at least let's go ahead and do that here. 0.04. Okay, very good. 0.04 is correct. All right. Good. Okay, so we have 0.04 is correct. That's what we'll go ahead and put in for R there. And the only thing we don't know is time, T, in years, because that's what they ask us to find. So that's fair. So let's go ahead and plug it in to our formula here that we have up top. And let's see what we get. And why not? All right, so what we're going to have here is, I'm going to go ahead and erase some of this here. So just need a little bit more space here. And work with that. All right. Okay, so we're going to have 10,000 here for A. So 10,000 times P, which is 8,000. And then this is times 1 plus R. And R here is 0.04, as we talked about before, times this time T, which we don't know what T is yet, but we're going to try and find out. So we're going to do our best with that. We'll see what happens, okay? Okay. Now, there are two ways to go ahead and solve for this particular type of problem here. But I think there's one way you could do it, which can be a little bit hard if you're not too good with the algebra. But if you want to keep it as simple as possible here, let's keep it as simple as possible. The first thing that we could do here in this problem is to go ahead and distribute the 8,000 here to both of these terms. So let's multiply by 8,000 in both of these cases to at least just get one calculation out of the way. So so we get 8,000 times 1 is 8,000. And then we get 8,000 times 0.04. And that is going to be, what is that going to be? That is going to be 320, I believe. We're getting at 320t. You can just use your calculator for that. I'm just kind of doing it off the top of my head. All right, so but I believe 320 is correct. All right, now let's go ahead and figure out what we need to do here next. As we can see here, we're trying to solve for t, so we're just going to go ahead and subtract by $8,000. And so here we get 2,000 equals 320t. All right. Okay, and then the last step here is, again, if we have 320t, we're just going to divide by 320 on both sides. Okay, so that way we can, again, balancing things out. And then obviously we'll have a calculator based answer for this, so let's do that. So t here is equal to, our final answer here, 6. Oh, there you go, you got it. Jasmine's got it perfecto, 6.25. So it'll take 6.25 years, 6.25 years, in order for us to finally get from 8,000 to $10,000. Okay, great. Any questions about that? Hopefully that isn't too bad. All right. All righty. You're good? Excelente. Excelente. Okay. Okay. Let's take a good look here at some more word problems. This time, though, again, this is the last section of Chapter 7 that we will cover. Again, in the book, there are more than 6 sections here in Chapter 7, but we're not going to do anything after Section 7.6. So 7.6 will be the last section of Chapter 7. All right, just to let you know about how that goes. All right. So, trying to find that. Oh, there we go. Okay. So in terms of content, there's not much in terms of content in terms of like new topic, but again, this is like more kind of advanced word problems here. We've talked about word problems so extensively in this class that we're talking about interpreting and then calculating here. So with interpretation calculation here, this is more about just kind of putting all that together now from a lot of the things that we've talked about throughout the course of the semester. So naturally, we'll see more of these word problems, for the concepts in the other 3 chapters after this. But still, same deal. So let's take a good look here at the first one. Okay, so I want to do just maybe 2 or 3 examples from here as well. Okay. Okay. Is that where I can find that one? Oh, I guess it's not there. All right, that's fine. It's fine. All right. Let's look at the first one here, which is number 5. Number 5, a masonry problem. Okay, so let's go ahead and read this off here together. All right, so there are 156 concrete blocks available to make a retaining wall. The bottom 3 rows will all have the same number of blocks. The next 6 rows will have 2 blocks fewer than the row below it. How many blocks are in each row? Okay, so again, we got 156 of these blocks. We got each of the bottom 3 rows, again, being the foundation or support of this particular wall, is going to be the same size, same number of blocks, I should say. And then every time we go up this, again, we're going to have 2 blocks fewer than the row below that. So this would be a case where if we look at this problem here, okay, this would be the type of problem where basically drawing a picture here is going to be incredibly helpful, okay? So let's take a good look here at what the picture of this wall is going to look like, okay, from a generic perspective. So we have the bottom 3 rows will all have the same number of blocks, okay? I don't know how many blocks that's going to be, but what we do know is that it's going to be some amount of blocks. So, but they're all the same size. That's one thing that we can take to the bank. So the bottom of this wall is going to look, something akin to this. Okay, so there we go. Okay. So let's say, for example, here, let's take an example here. All right. Let's say this example here, since we don't know how many blocks are in each row. Okay, since we don't know how many blocks are in each row, let's call that X. Okay, so there's X amount of blocks here, the same X amount of blocks here, and the same X amount of blocks here. Again, we don't know, but we do know it's some X amount of blocks for these foundational aspects. Now, the next row of blocks is going to be a bit shorter. Okay, it says here, the next 6 rows will have 2 blocks fewer than the row below it. Okay, so let's look at it from this point of view here. Let's say, okay, here's the next level, but now it's a little bit shorter. Okay, so it's just got a portion kind of lopped off there. What would be the expression of this next level? Let's say we put it in terms of X. What would we have here for this this part of our brick pyramid here, I guess is the best way to kind of put it. So what expression should I put there for this level? We take a good look at the problem there. So again, just be a little careful, but if you look at the problem there, it should be clear about what we need to be doing there. All right, -2. What -2? So that's important here, Jasmine. What -2 exactly? X -2. That's right. Okay, good. Because we have okay, so let's read this carefully here. We have 2 blocks fewer than the row below it. So the row below it has X amount of blocks. So this one here has to have 2 blocks fewer than that. So that's going to be X -2. Okay, X -2 blocks. Now remember we have 6 of these rows here. So let's go up to the next level. This is going to be, again, slightly shorter. This time, though, I have 2 blocks fewer than the one below that. So it was already X -2. So what I have here is I have X -2 blocks, but then I'm subtracting 2 from that. Okay, another 2 blocks gone, since that's what's going on here in this, again, this little tower. What I actually have here, the amount of blocks, I have X -4 blocks instead. Okay, so I have X -4 blocks here. If I keep going up the levels here, hopefully you begin to see a pattern. 3, 4, 5, 6. Okay, so here I have X -4 blocks. I subtract 2 from that. I get X -6 blocks. I subtract 2 from that. I get X -8 blocks. Here I get x minus 10 blocks, because again, I just take off another 2 blocks. And here I get x minus 12 blocks, just like so. Okay, so 1, 2, 3, 4, 5, 6. Okay. All right. All right. Are there any questions about that so far? So if you read this carefully here, so the bottom 3 rows will have the same number of blocks, right? The next 6 rows will have 2 blocks fewer. So there's actually 9 rows of blocks. The first 3 rows are the foundations, and then the next 6 rows after that have the condition of having 2 blocks less. So that's why in my picture here, you see 9 levels. Yeah. So the wording there, you have to be a little bit careful. So that's why, yeah, I can understand why that can be confusing here. But again, if you need to, reread the problem there so that way you get a full understanding of what it's asking you. Okay, so yeah, that's a common thing. So I'm not, trust me, I'm not mad. It's just one of those things you have to be very careful of. As we always like to say, the devil's in the details. All right. Now what we're going to do here is we're going to add up all these x's, okay? That's fine. That's fine, Jasmine. All right. So we're going to add up all these x's. So we're going to have x plus x plus x plus x minus 2 plus x minus 4 plus x minus 6 plus x minus 8 plus x minus 10 plus x minus 12. And somehow, someway, after all this, after we add up all the amount of bricks in each one of these 9 rows, somehow that's going to equal a total of 156 bricks that we use for this retaining wall. Why? Because that's the number they gave us. Now let's go ahead and see how many x's we have here. Again, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we get 9x here. We add up the x's together. We get minus 2, minus 4, which is minus 6, minus 6, minus 6 is minus 12, minus 12 minus 8 is minus 20, minus 20 minus 10 is minus 30, minus 30 minus 12 is minus 42. Okay. Okay. So this is the equation that we're working with here so far. 9x minus 42 equals 156. Okay, so what do we do next? How do we solve for x here? What do we do here? Divide 9 to both sides? Well, we got another roadblock in our way here, Jasmine. We have 9x minus 42 equals 156. So 9x is okay, but we can't deal with that just yet. Got to do one more thing before then. What should we do then? What do you think? All right, guys, you guys should know your algebra by now. Come on, guys. All right, that sounds like a plan. I like that. So you got to remember here, in algebra, everything is a balance. All right, I'm going to add 42 to both sides here. All right. We're going to 9x is equal to 156 plus 42 is 198. Yes, that's correct, Ruchi. All right, and then what do we do next? How do we solve for x here? All right, how'd you get 22? Yeah, then we divide by 9 on both sides. All right, and that is exactly where we get 22 for that. That's correct. So here we would have 22 bricks and 22 bricks and 22 bricks, and then just go down the line here. All right, and there we go. Nice. Again, everything in algebra is always a balance. It doesn't change. So that's how we do these problems here. Simple enough. Simple, simple, simple. All right, let's go ahead and do one more problem here. And yeah, let's do that one. It's one of my favorite problems. Let's do this problem here, and we'll end off here for today. For today. Let's see. All right. Let's take a good look here at the very last question of this section, which is number 27, manufacturing question. A conveyor belt 24 inches wide is moving boxes that are 12 inches wide and 18 inches long. Using the full width of the belt, how fast, in feet per minute, would the belt need to move in order to unload 6,400 boxes in an hour? Assume that the boxes are placed end to end with no space in between them. Okay, so we got just a long conveyor belt, and we're trying to unload 6,400 boxes in an hour, knowing the dimensions of each of the boxes itself. Okay, so much like the last question where we had a group of bricks here, in this case, drawing a picture here will be incredibly helpful. Let's take a look at that. Okay, so if we're at the factory here, for example, all right, in this case, we're going to have a conveyor belt here. Let's just imagine that this is our conveyor belt. All right, and that the distance of this conveyor belt here, according to our problem, is going to be 24 inches. All right, so we're given that fact there that that's how wide this conveyor belt is. It is what it is. Okay, now we're also given the dimensions of one of these boxes. All right, so the dimensions here, let's go back to the problem here for just a moment, is that one of these boxes is 12 inches wide and 18 inches long. So kind of a longish type of box, but let's go ahead and physically represent it as just a simple picture. So here's what a box will look like. A box will look like this. So say it's here. Again, it's going to be a little long, but again, key difference there. So here it's 12 inches wide and 18 inches long, just like, yeah, just like that. And that's what the box generically looks like from a top-down view. Okay, so let's answer this question here. We're trying to move 6,400 boxes, right? That's the goal here. We need to figure out how many feet per minute. Like, you're like, what? Okay, it's kind of weird. Well, one thing we can answer here, if we can use all the space on the conveyor belt, how many of these boxes can we put side to side to use this conveyor belt? 2. That's right. Absolutely. So because this is 12 inches wide, okay, we can put 2. Realistically, we can put 2 here since we can use the entirety of the conveyor belt. So we could just put it side to side like here. Okay. So here we go. And here we go. Since we can assume that there's no space between the boxes here. So again, this is 12 here, this is 12 here. All right, we're going to have 18 here again for this for that side. All right. In any case, in how much time do we have to move all those boxes? Well, that's we're trying to move those boxes in an hour. So we're trying to move 6,400 boxes in 1 hour. Okay, so that's like saying maybe that's the company's quota of moving how many boxes of whatever they're making. Got to move 6,400 boxes in an hour. And we know that we can at least place 2 of these boxes side to side, on the conveyor belt since we can use the entirety of the conveyor belt itself. All right. Having said that, one thing that we do know here is since we can put boxes side to side here, we could put a pair of boxes here. We know that there's going to be 3,200 of these pairs of boxes. So we're going to look at 3,200 pairs of boxes. Okay. And we do need to get this done in an hour. Kind of a stretch, but okay. We'll give it a shot. Let's figure out how long, how many, we know we got to get 3,200 pairs of these boxes done in an hour. Fair enough, but how long is it going to take us to do that? So, how many, what's the length of these boxes, these 3,200 pairs of boxes end to end? So we do know that it's 18 inches long here. And that's actually going to be very important. Because if we're going to find the number of inches that this should take, 6,400 boxes represent, we're going to take 3,200, we're going to multiply by 18. Okay? That'll figure how many inches of boxes that we're going to go through to represent the 6,400 boxes that we need here. Anybody got an answer for me here? 3,200 times 18? Yeah, it'll be done in an hour, but we're going to factor that in just a second, Brenton. So 57,600. Okay, let's take stock in what we got here. Okay, so we have 57,600 inches here. Now, the reason why I want to stop here, got to be a little bit extra careful about this problem. Okay, let's go back to the problem here for just a moment. What we want, and it's just kind of go back to what Breton had said just a second ago. What we want is we want feet per minute. Those are the units that we want because that's what it asks us to find. We have to find feet per minute. What we have here is we have 57,600 inches and we have 1 hour, as was correctly stated before. So right now, let's look at what we had here. We have 57,600 inches. And we want to make sure that that gets done in 1 hour. Exactly stated. Again, what we want here, though, we want feet per minute. So the units here are going to make a significant difference. Okay. So let's change hours into minutes here. I don't think that'll be too tough. So we're going to put 60 minutes here on the bottom and 1 hour on the top. And that way that will cancel out our hours units. And one on the top, one on the bottom. How about this? 57,600 inches. What should we do here? We're trying to convert that into feet. So what conversion should we use here to convert inches into feet? Okay, good. So we know that 1 foot equals 12 inches. So we have 12 inches here. And we got 1 foot here. So 720 feet per minute. Now you got to be a little careful here. Remember, it's dependent on the amount of boxes that we have here. So what we want to have happen here is, I don't know if that's 720 off the top of my head, to be perfectly honest, but we're going to find out. You may be right about that, though, Ruchi. So we got 57,600. And then what we have left over here is cancel out the inches here. We got the feet. And then we're dividing that by 60 times 12. Okay, so on the calculator there, this will be a calculator thing after this. So again, 57,600. And we'll divide that by 60 times 12. Okay. Again, remember 60 times 12 should be in parentheses there. All right. And what do we get here as our final answer? Yeah, 80. Okay, 80 is going to be our final answer for that. So that's how we're able to put that all together. The 720 part is for the bottom part here, Ruchi. So we did 57,600, divided that by 720 there. And we actually ended up with, in this case here, 80 feet per minute would be our final answer. So I bet I know what happened, though. Let me see if I'm right about that, though. Oh, maybe not that way. Maybe not. All right. Thought maybe, but no. That was not the case. Okay. That one's a little bit tough, okay? That can be just a little bit tricky, okay? But it's not as bad as it may seem. It's just again, relatively straightforward. It's pretty easy. So there you go. You got it. Any questions? No? Okay. Excellent. Dr. Dan, Brenton, Ruchi, you have any questions? Hey, that's okay. Look, to be honest, it's okay it's okay. It's okay if you didn't get the right answer the first time. Remember, it's a matter of learning. So, you don't have to be right all the time. You just have to be able to want to, learn from the mistake and then hopefully be consistent with the process. Oh, you divided by, okay. That makes sense, yeah. Yeah, trust me, when it comes to mathematics or, in numbers in general, if you don't get it right the first time, go back and try it again. So, you know, consistency is really what's key. So even in the real world, you got to be consistent. You know, you're only human. You can only make, you'll make mistakes because that's only natural. But once you get consistent at your job there you go. Hey, that's cool, man. I have no problem with that. Yeah, it'd probably be one of those you could use a calculator for. So what I love about consistency is like, oh, I can be wrong sometimes, but as long as I correct that, no problem. All right. Ren says good, and Dr. Dan says just trying to take doing the notes and trying. Okay. All right. Any questions about the entirety of chapter 7? Again, this is pretty much like a lot of practice here with algebra, but it shouldn't be too bad. Calculator. It's maths time. Yes, yes, it is, Connor. Yes, it is. It's always maths time. Yeah. It's always music time. Yeah, again, it's just a lot of logical process and thinking. So, again, you just kind of have to start putting the pieces together. Remember, all word problems and all critical thinking problems is always going to be about interpretation and calculation. All right, none of those things, both of those things are going to be your two major pieces. Pretty much what we talked about at the beginning of the class, in this part, in this section especially, and heck, once we get to the end of the class talking about some basic trigonometry, there we go. Easy peasy, lemon squeezy. So, interpretation, calculation. That's why the setup there is so much more important than actually doing the numbers out. Next question. That was my last question, Ruchi. Um. Oh, okay. This is for 7-6, JC. This is for 7-6. Oh, let me turn down the volume then. That's okay. Sometimes you just need to turn that volume. Yeah, so that's for section 7.6. Sorry about that, JC. Oh, that's right. You have me on mute. There we are. Now I can turn that up a little bit. This was number, specifically number 27. The last question there from that section. Yeah, because section 7.6 is just, yeah, let me reiterate that here one more time. So, do you guys want music for the future streams? I've been defaulting to kind of putting it off because I know I asked before, but I keep forgetting whether or not you guys want music or not, so. Gotta have vibes, Connor, man. Gotta have vibes. You down? Okay. If you're down with that, I'm chill. It's all good. Excellent. I don't mind vibing, learning math at the same time. Yeah, all right. That's all good. You guys have the right to tell me what to do, So, as much as I do. So, you guys say, "Hey, I want to vibe a little bit in the morning." Hey, I got no issue with that. None whatsoever. You know how it works in this class? It's a process, but I'm no dictator. Ugh. Hmm. Yeah, that was the last question there, Ruchi. I apologize. You came in a little late, so but you get, I'll be on here for I'll be on here a couple more times later today, doing a couple more subjects. So It's 5:30, but still morning vibes. Yes, it's 5:30 over in Ireland. No problem, bro. Right now it's about 11:30 here in the morning. So there you go. 5:30 p.m. if 11:30 a.m. here. Yeah. That'll that'll take care of it for today. Um, yeah, that's pretty much kind of what I want to put out here. But like I said, if you want to come back to my stream here, like Richie, if you want to. Oh, okay. You have a good night, Ruchi. You have very good. Where are you at, Ruchi, if I may ask? Test is due Friday. Yeah, test will be due Friday. Yeah, I want to know where Ruchi's at. Like which country? Oh, you're in India? Right on, brother. All right, you're in India at this time. Right on, man. How's the weather out there? Is the weather how's the weather out in India? It's nice in the winter time, from what I hear anyway. It's winter over here, so it's hot here right now, even winter. Oof, brutal, brutal. Well, I could use some warmer weather than what I got over here. So I'll uh I'll take that anytime. It's 60 degrees. It was like super cold last night. I had to wear my army coat and stuff. Rain and wind all day. Wind warning today. 100 kilometers per hour. What? Holy cow. You might as well just not step outside. Because, I mean, the wind's going to just blow you away. Jeez. Holy moly. 100 kilometers per hour. Yeesh. Um, yeah, outside is a kind of a is kind of like a foreign country to me without the visa. All right. That's how I kind of look at outside. Like I don't need no passport to go outside, but I'm still not gonna go anyway. No, I believe you. I believe you. I believe you. Soccer train tonight. Okay, body warmer and jumper. Yeah, body warmer and jumper to do the job if you're used to it. Yeah. What position you play, Connor? Like there are times where I just haven't gone outside like for days on end. So that's just because I'm just a homebody. I'm a super hermit. So Yeah, I can't really argue with that. Get that vitamin D. Although VD can be interpreted another way. Not so nice. No, nobody wants that part. That other interpretation is not what we're looking for here. No. Right on, right on. Nah, center mid, right wing, and left wing. Okay. I like to play in goals though. All right. I guess it just depends on your favorite foot. If you're a right-footed, then right wing's the place for you. Get those crosses in. I know what position I would play if I was doing football. And I'd probably be on the defensive side of the ball. I'm not the kind of guy who wants to go score goals, but I am the kind of guy who wants to prevent them at all costs. All right. You gonna take your puppy is biting you? Oh no. All right. All right, everybody. I want to thank you all for coming out here today. All right. Thank you all so very much for coming out here today. I want to wish you all a very nice day. No. No, you do not. No, you do not. Brenton. Yeah, do not do 7-7, 7-8, or 7-9, okay? Oh, Huskies are super. Oh, I'm Ronaldo. Yeah, I'm a little out of shape to be Ronaldo. I'm not. I'm neither Ronaldo. Okay, I'm neither the Brazilian Ronaldo or Cristiano Ronaldo. Um, neither of them. Yeah, only do sections 7.1 to 7.6. All the homework's already posted on my math lab, so those are the only sections that you should see there. Okay? Shave my head, but look, my father's lineage has already given me this pre-shaved look. Shave my head like Brazil Ronaldo. I'm not like super bald. I could shave it to like I could do like a number 2 razor at the hair cutting place, but that'll take like all of like 5 to 10 minutes. And then I'll be pretty much bald again. And then this grows back. And then I play pretend for a little while, and then I'm like, yeah, let me save money by not going for a while because it's not going to grow any further. I'm like, okay, that's cool. The front will do the job, as in the whole front, every front. And I'll eventually shave my beard, and then I'll be like 20 years younger again. And yep, that's and that's the cycle right there. All right, everybody. You guys have yourself a very wonderful weekend. If you want to come for my next class, it's fine. I'll be back at 1 o'clock. So, can I email the notes? There's not many notes to really be had here, Brendan. I'll just show you really quick. This is all do you want these? I mean, this is all I wrote. But if you want this, I'll send it to you. No problem. I know I've sent you the last few notes here, so if you want this, Brenton, then you know, just say so, and I'll just send it over anyway. I don't have a problem with that. No, all right. Yeah, I didn't think you'd want the notes if there were just like 3 lines to really look over. So, but that's why I'm asking. So, if I wrote more than this, I would definitely give it to you. So, all right. Okay. Thanks again, everybody. We're gonna see you. I'm gonna see if you won't come back here for my stream. I'm gonna be back in an hour and a half. Okay. Otherwise, I will see you next week. For those of you in this class, okay, thank you very much. Okay, have a wonderful weekend. Please take care of yourself. Stay safe, stay happy, and stay healthy. Okay, and stay sane. That's the last important part. Okay. All right.